Question 1.5. Here we need to compare the concentrations of the species at equilibrium. This is the equilibrium reaction. To determine the relative concentrations of the species at equilibrium, we can use an ICE table, where I is the initial moles of each species, C the changed moles, that is the moles of each species either used up in the reactants or produced in the product, and E is the number of moles present at equilibrium. We are told that the moles of the two reactants are equal at the start of the reaction, and so let's call their values A, since we do not have their actual mole values. At the beginning of the reaction, there is no hydrogen iodide, and so its mole value is 0. Then the line on the table for the changed moles always has the values in the same ratio as the stoichiometric coefficients in the balanced equation. In other words, the changed moles depend on the molar ratio. So since 1 mole of hydrogen reacts with 1 mole of iodine to produce 2 moles of hydrogen iodide, if we then say that X moles of hydrogen reacted, and we are calling it X because we don't know the value, then the same number of moles of iodine must also react according to the balanced equation. And double the moles of the product must form, that is 2X. Then, to work out the moles of each reactant present at equilibrium, we must take the moles we started with and subtract the moles which were used up in the reaction. And we get A minus X moles for each reactant left at equilibrium. And for the product, we need to find the sum of the initial moles and the moles that were produced. And we get 2X moles. We can see that no matter what the actual values are, that the equilibrium moles of the two reactants are always equal. But the answer options are in terms of concentration and not moles. And we know this because the answers are written in square brackets. Since concentration is equal to moles divided by volume, we can write the concentrations of the two reactants like this. But all the gases are in the same volume, the same vessel. Therefore, the concentration of hydrogen gas and iodine gas must be equal at equilibrium. And so the answer is A.